Clear, guys? Are you clear?
Yes, sir.
Yes.
Now move to the next one. Normal distribution. Put a 5-star, okay? Because you'll be hearing about normal distribution every now and then from now. Guys, every now and then I'll be always taking the name of normal distribution. Okay? Why? Because this is one of those distribution which is where the calculations, right, are pretty easy, right? And also most of the natural problems will fall, or which will follow a normal distribution, right? Let me tell you a interesting, just give me a second. I'm just trying to pull a YouTube video. Okay, it is generally called as Galton board. Okay, let me just show you. Just give me a second. I'm just sharing my screen too. You'll be really surprised. Guys, how many of you have seen this before?
Should we hear something, Dhanush? Because I'm not
Uh,
able to hear anything.
no, just observe. So sometimes voice is not required to understand.
Okay.
Okay. So you see what he's trying to have a funnel shape in the top of it, right? And he's trying to put a lot of different balls, and there are a lot of nails. So even if you're trying to put a ball in a certain position, it is always not falling into the same vertical column. Agree? Agree? Make sense? Are you clear? He's just trying to, as you're saying that I'm just trying to put a ball always in the same position on the top, but still it is trying to land upon a different position, right? You see this?
Yes.
Yes.
Right? It means after a certain experiment, it means if you're trying to conduct this experiment more number of times, after a certain period, it will slowly start falling as a normal distribution. So this is the beauty of the nature. The nature, if it is being conducted for most of the problem statements, right? Slowly after conducting a number of times, it will slowly follow a normal distribution. Again, don't select exactly looking like a normal, but as I said, it has to be conducted more number of times. Interesting point, right? So this is generally called as Galton board. Okay, are you clear? So this is the reason
Yeah.
why most of the statisticians assume something to be of normal distribution. Now, not just for the sake of simplicity, but most of the common real world problems, right, will tend to follow a normal distribution. So there's a much of the research work, right, in the world of statistics has been done on the normal distribution. Okay, clear about this? Yes, makes sense. Are you clear?
Yeah.
Right.
Yeah.
So yes, actually, right, all our real world, right, it is revolving around mathematics. It's just that we don't pay attention to it. Okay, so that's the reason we say stats, machine learning, or data science. This is like one of the exciting subject, right, where you can relate to your with respect to your real world lives and real world scenarios. Okay, now let's try to understand what is normal distribution before we talk about any of the other things, guys. Any, because we have come across normal distribution on a very high level. Can someone point me in which particular session that we discussed or related or talked about the normal distribution?
I think while discussing about shapes.
Excellent. Very good, Mohnish. As when we were trying to discuss the shapes, right? We discussed about skew towards the left, skew towards the right. What was the middle one? It was the third type.
Symmetric.
Remember? Symmetric. The moment we say symmetric, it is nothing but a normal distribution curve. Agree? At that point of time, I talked bell-shaped curve also. Right? Orally, it was not documented, but I just talked about this particular point orally. Right? So this is the reason why, because normal distribution, right? Any distribution where you can see a bell-shaped curve, where it follows the property of symmetry, where each half of the values around the center is equal to the other half of the distribution, where mean, median, mode will coincide, right? We label such a distribution as a normal distribution. Are you clear about this, guys? What are the properties that it needs to maintain? Can someone quickly repeat with me? What are those three things?
It should be symmetrical.
Very good.
Mean, median, mode should coincide.
Yes.
And how values are towards the center.
Yes. So each
Around
half
the
of the
center.
values on the center are equal. Okay. So it means if I'm trying to cut through the distribution curve through the central tendency value, then it will result in two equal halves. Okay. So the moment you treat such kind of an properties, right, we can label them as normal distribution. So since it's a normal distribution, will I have a PDF or PMF?
PDF.
PDF. Okay. So we'll have a PDF value and how the function would be. It would not be that easy where you can remember that easily, but give it a try. If you remember, then you're great. You can go for Parle-G ad. Okay. Keep them handy so no one will try to ask you those formulas, but by any chance if you remember, then you are great. Okay, so the expected value of E is this is mu, and the variance of this is nothing but sigma square. Okay, so this is how the E of x and V x value will be concluded, and come to some of those examples. Okay, so what kind of examples that I can take? Right, I'll not be taking normal example, but you'll be really surprised, right? The heights of people, right? When you try to take considered amount of people, right, then the heights would tend to follow a normal distribution. I said most of your real world problems, right, will follow a normal distribution. Just that we need to consider enough number of data points. I do not consider 10 data points, say like Dhanush, it is not following a normal distribution, right? We need to take considerable amount of data. Make sense, guys? Are clear?
Yes.
Are you clear? Very good, right? So how does the normal distribution will look like? So the normal distribution will look like something like this. Okay, so the moment we talk about normal distribution, you need to remember two important points. The two important parameters or characteristics that you need to remember is mean and standard deviation. Okay.